Okay, so we have discussed like isomerism and also like the naming, how to name different hydrocarbons. So this was examples that we have done. Like this was 2-methyl and propane. This is 2-methyl butane. And then I told you that in corners there is no branching basically. Branch should be either on like middle on the second carbon and on the third carbon. On the first carbon there is no branch. It's part of long chain basically. It's a part of long chain, right? So when it's a part of long chain, so basically you can say that let's suppose it has four carbon atoms. So this would be butane straight away. This is butane. So like this is not, you can say, not 1-methyl and propane. No. Okay. Getting my point?
Yeah. Yeah, I understand.
Okay. Then physical properties. Of alkane. And also alkene basically. When we would be discussing alkene, so I would be telling you the physical properties are same. I'm supposed to write physical properties of hydrocarbons. Physical properties of hydrocarbons. Can you tell me what is homologous series?
Sorry, sir?
Can you tell me what is homologous series?
Homologous series?
Hmm?
Okay. Homologous, like their collection of different compounds. They have the same formula, but they only differ in the number of carbon.
Basically, the series in which the difference of two consecutive compound is CH2. The series in which the difference of two consecutive compound is CH2 is a homologous series. Like I told you that, let's suppose this is methane, ethane, propane, then butane, then pentane. So the difference is CH2. So the difference is CH2, 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 CH2. So this is homologous series in which we have methane, ethane, propane, and butane all belongs to the same family, that is an alkane, and they have the same functional group. They would be having the same chemical properties, but they would be having different physical properties. So why they are having different physical properties? Like today we are going to like discuss that. So physical properties of hydrocarbons. Number one, should be gas, should maybe liquid, and maybe solid. Basically depends. Basically depends. Like let's suppose as the number of carbon increases, then you can say that intermolecular force of attraction increases. I mean to say van der Waals force increases. So this is the reason, due to the increase in intermolecular force of attraction. So due to the increase in intermolecular force of attraction, you can say solidity increases. Solidity increases. Like let's suppose CH4, then CH3 and CH3, then CH3 and CH2, then CH3. As you can see, this is gas, gas, then liquid, then liquid, then liquid, and then it would be solid. Then it would be solid, right? So,
Yeah.
so as you can see, the number of atom increases as we are going down the group, like we are going down, the number of atoms increases. Due to this, number of electron increases. When number of electron increases, so I can say van der Waals force is a type of intermolecular force increases. So like the thing becomes liquid, like gases have a weaker force of attraction, and the liquids have a stronger force of attraction, right? So due to this, then examiner would be giving you the two or more hydrocarbons, and we would be asking to do a comparison between these two. So you would be having, like, you can count the number of atoms or number of electrons. So number of electrons are directly proportional to the van der Waals force, like you can say the intermolecular force of attraction. So this is the reason, as you would be going, like the number of carbon increases, as a result in increase in number of carbon atoms, increase in number of carbon atoms, so you can say that the solidity increases. Not only this, it also affects the melting and boiling point. It also affects the melting point and boiling point. So this was the first physical property, and then we have another one, that is, as the number of carbon increases, so the intermolecular force of attraction increases, like the van der Waals force increases. Means that when van der Waals force increases, so melting point and boiling point increases. Okay, melting point and boiling point increases. So again, let's suppose, okay, so basically this is what I mean, okay, that when the number of atom increases, so the number of electron increases, so intermolecular force increases, so melting and boiling point increases. Same goes with the density as well. Same goes with the density as well. Like the density is again directly proportional to the number of atoms. Means the density is directly proportional to intermolecular force, like the van der Waals force. And then they are insoluble in water. Can you tell me why?
So what is insoluble in water? Sorry, I was writing the notes down.
Alkanes,
The
like
alkane.
hydrocarbons. Like hydrocarbons are insoluble in water.
So yeah, they are. So
So why they are insoluble in water?
because they have difference in the electronegativities of hydrogen and carbon. They have different.
Basically, you can say that all
They're non-polar.
exactly all hydrocarbons are non-polar, while water is polar substance. So remember, like dissolves like. like dissolves like. So if you are going to dissolve these hydrocarbons into a non-polar solvent, so it would be like if they will dissolve basically. So they are soluble in non-polar solvents such as hexane, we have other non-polar solvents as well. So those things, like those compounds which are insoluble in water, as you know that the water is a polar substance, so they will be completely soluble in a non-polar solvent ultimately. So this is the physical properties of these are the physical properties of like you can say hydrocarbons or alkanes. Then we have chemical properties. And also one thing I should tell you that let's suppose you have two compounds. This is having this is butane. Formula is C₄H₁. This is what's the name of this? Yes.
Okay, so this has 3 carbon and so when you write H3 next to it, means that carbon has 3 hydrogen, right?
First of all, you have to select long carbon chain.
No, sir, I'm not asking that. I'm asking if the you see how in some of the next to some of the carbon there's CH3. H3 means there's 3 hydrogen for that specific carbon, right?
Basically, the valency of carbon is 4. It has to make 4 bonds. So that's why it has made 1 bond already. So that's why I need to write 3 bonds more, just like that. That's why I have written CH3 and CH3. The same things, H3C and CH3, the same thing. So what you have to do basically, you have to select the long carbon chain and then you have to select the branch and then just number it.
Oh, okay. Wait, let me write it down first.
This is in long chain. I have 3 carbon atoms, right?
Yeah.
And this is a branch.
Oh, sorry.
What's the position of the branch? So it's 1, 2, and 3. So this is 2-methyl propane.
2-methyl
Like
propane. Yeah, I
according
was
to the
saying
rule.
that. Oh, I
Yes.
said
Okay.
methyl
Okay.
butane.
Okay.
Yeah, it's methyl propane.
So can you tell me which one is having high melting point and which one is having a low melting point? So you have the two compounds whose chemical formula is the same. As you can see, it's also C₄H₁. So like they would be having the same melting point or different melting point. If you say that they have different melting point, so then you have to mention which one would be having the low melting point and which one would be having the high melting point. Yes.
Okay, wait, let me. Okay, so during structuring. So the melting point of butane, butan, So it's since it's so since both of them have the same molecular
It
formula but different structure.
it looks like that. It looks like
They have
that
the
they have
same
the same, yes, molecular
molecular,
formula.
but structural, they're different structurally.
So they are isomers of each other, right?
Yes.
So when they are isomers of each other, but they have the same molecular formula, so but their like you can say melting and boiling point would be completely different. Why? Because I
Yeah.
told you that intermolecular force depends on the two factors. The first one is the number of electrons, and another one is the surface area. So if you can see,
Yeah.
like let's suppose it's occupying 3 centimeter, 3.2 centimeter, let's suppose, like it's occupying this much, right?
Hmm?
So, and it's occupying just 2 centimeter, let's suppose. If you can see, it's occupying 2.2 centimeter or 2.3, something like that. So basically, it has more surface area, less surface area.
Yeah.
So I can say that more surface area means more intermolecular force. Less surface area means weak intermolecular force. So okay,
Yeah.
yes. Then we have chemical properties. Chemical property, like the first chemical property is combustion reaction. Combustion means what? Combustion means what? It's burning. And when the thing burns, oxygen is necessary. Oxygen should be there. Oxygen should be there. So basically, remember, oxides would be formed. I would be explaining what is meant by the term oxides would be formed. Basically, we have two types of combustion. Number one, complete combustion, and incomplete combustion. First one is complete combustion means when there is excess of oxygen. plentiful supply of oxygen. So let's suppose this is methane and this is ethane. This is propane. This is butane. This is pentane. I'm going to react with oxygen. I'm going to react with oxygen. Going to react with oxygen. So remember, I told you the oxide would be formed. So the oxide of carbon and oxide of hydrogen. So oxide of carbon is carbon dioxide and oxide of hydrogen is H2O. Product would remain the same, just like this, just like this, just like this, just like this. Then you need to balance this equation. Then you need to balance this equation basically. So remember, for these reactions, like for the combustion reactions, if you are going to balance this equation, so we can balance it very easily. The number of carbons are equal to the number of carbon dioxide. Okay, the number of carbons are equal to the number of carbon dioxide, and the number of hydrogens means like the half of water. Let's suppose one carbon dioxide, four hydrogens, two water, two carbons, two carbon dioxide, six hydrogens, three water, three carbons, three carbon dioxide, eight hydrogens, four water, four carbons, four carbon dioxide, eight hydrogens, four, this would be C4H, C4H10. So it should be 5H2O. If there is 5 carbon dioxide, so 12 hydrogens means 6 water. So basically, carbons are equal to carbon dioxide, but the hydrogens equal to the half of water. If you have 10 hydrogens in the reacting side, so you must have 5 water in the product side. So the water is approximately the half of, you can say, hydrogen atom. So now you need to balance oxygen. Now you need to balance oxygen basically. So how many oxygens? 2 and then 2. So there are 4 oxygen atoms. So already I have 2 oxygen atoms. So I'm supposed to write 2 over here. Now this is balanced. So here 2 into 2 is 4 and 3 into 1 is 3. So in total there are 7 oxygen atoms. So I already have 2 oxygen atoms. What am I supposed to write down the number so that I must be getting like the 7 oxygen atoms. So I am supposed to write 7 upon 2. 7 upon 2 because they would be cancelled. 2 cancelled. So remaining 7. So 7 means like 2 into 2, 4, and then plus 3 into 1 is 3. So total 7 oxygen atoms. That's why we need to have a balanced equation. We need to make it the same number. So now this is balanced. Then we have propane, then we have butane, then we have pentane. Now tell me how many oxygen would be needed in the third equation? Yes.
How many oxygen would be needed in which the third one, right?
Yes. So what do you think in the third equation?
The third, wait, let me see. Yeah, you need 5.
Okay, great. Like you can say this is 3 into 2 is 6 and 4 into 1 is 4. So 6 plus
Yeah.
4 is 10. So already I have 5. So I need to multiply that with 5 to make it 10. Yes. Okay. For the next equation. So 4 into 2 is 10 and 5 into 1 is 5. 8 plus 5 is 13. So mean we are supposed to write 13 by 2.
Yeah,
Okay.
or yeah,
Not 5.
I
Okay.
just
And
did
for the
the
next.